Hey everyone, thanks a lot for joining me here today on this substance education webinar. So what we're going to do today is take a specific look at physically based rendering and shading. So this is really not going to be specific to the substance tools themselves. This is going to be just really kind of a more of a theory and practical guideline to rendering with physically based materials. Before I really dive right into the content, just give me a quick shout out in the live chat. Just let me know that you hear me okay. Just want to make sure my audio is good before we jump right in. All right, perfect. So got a little confirmation there. So let's just jump right into the course. So one of the things I'll also mention too that I'm going to be monitoring this live chat as I kind of talk through this. So if you guys have questions, just post them in the live chat, and we can address them as we go forward. So don't feel like you're going to interrupt or anything. It'd be great to get some feedback, and we can kind of move this kind of in any direction we need to go as we start to work through this. All right, so here we are, embracing PBR. Now, like I said, this is with substance, but really we're just talking about PBR in general. Okay, so one of the things I like to do when I first start to teach like a PBR course is I like to define what is PBR. And so you hear a lot of buzzwords with PBR. Sometimes you hear PBR, sometimes you hear PBS. Basically, PBR stands for physically based rendering, and if you hear PBS, that's physically based shading. Even though there is a pretty good standardization of physically based rendering, you'll also notice that there's a lot of deviation in that standard as well. So I like to wrap this up as describing what PBR means to me is that it's a method of shading and rendering that provides a more accurate representation of how light interacts with surfaces. So here, again, we're really stressing the point of the light interaction with surfaces and what happens to that light, how that light is bounced, reflected, diffused, and so on. And so that's really what it's all about when it comes to creating these materials and maps that we're going to be working with. So with this, one of the things that sometimes get asked a lot in introductory PBR classes is like, oh, okay, well, why am I doing this? What are the benefits? Why? I mean, I know how to do it this way. Why am I going to learn this PBR stuff? And so one of the things, the very first, I don't even have it listed here in my 1, 2, 3 bullets, but one of the very first things I'll say is because it is the industry standard now. So it's one of those things where it only helps you to learn this because this is the industry standard going forward. The other thing in terms of creating maps and working with the content, number one, it's easier to create the materials because it removes all this guesswork from authoring materials, or I say surface attributes. And by that, I mean, I've been doing 3D for a really long time, and I'm not sure about everyone's background that's here in this seminar, but like if you're new in school and maybe you guys are only introduced to PBR, I'm not really sure. But before PBR, we had, just regular shading. So we had like, blend, Phong shaders and so on. And so a lot of the, workflow that we used was, it really had a lot of guesswork, at least it was to me. So for example, like I would look at something, I was really terrible at texturing. Like I hated it. It was like the worst process for me, which is funny because I work for a texturing company now, but it was one of those things where I was like, I have no idea what to do with this. I don't know how to make this reflective. I don't know how to make this like metal. Oh, it looked like metal in this particular render, but as soon as I move the light, doesn't look like metal anymore. And so you would see a lot of people doing tricks like, okay, we're going to add ambient occlusion into the diffusion because it makes it pop a little bit more. And, if I have this light and this bounce light and all this stuff, in this particular frame, it looked like a metal and so on. So there was a lot of guesswork in trying to determine, well, how reflective is something? What is the value of this metal and so on? But with PBR, you throw all that out the window because it's based on scientifically measured data. That means that there is no guesswork. There's a number, It's a scientifically measured value. We just enter that value and the shader does what it needs to do, which is awesome. So like we don't have to worry about any of this science stuff. I mean, it's really awesome to know it because the more thorough you know it, the more you know how to break rules, the more you know how to author materials that you can't find values for, and so on. And that's really what this course is about, getting us to understand the theory as well as the practical guideline behind creating these maps. So that's number one, and I think it's like one of the biggest ones. Number two, and I've kind of hinted on this already, is that materials will look correct in all lighting conditions. And like I said, going back to kind of the old workflows, I guess they refer to as traditional workflows, you would set up, just crazy lighting scenario, and maybe your metals and plastics and everything look great right then. But as soon as you put that into a new scene, like maybe it was an indoor scene and you moved it to an outdoor scene, you had to like change stuff. You would have to, me personally, I'd have to jump back into Photoshop and like tweak values and, okay, this is too glossy now and so on. But with PBR, again, throw all that out the window. It doesn't matter because it's based on scientific principles. So it's going to work just like in the real world, hence the word physically based. So like we don't have to worry about it. It's going to look good indoors. It's going to look like a metal outdoors and so on. And I say look good. I mean, that depends on what we do, how we author the maps. And we need to make sure that we author the maps correctly. And we'll get into that in this class. But that brings me to the final point, which is it provides a workflow for creating consistent artwork. And this is one of the reasons why it's adopted so much in production facilities, because time is money, obviously, and you guys are learning that in school as well. And as you're gearing up for, moving on and working in a studio of some type, the more consistently artists can create materials and have them look correct, then it's just a huge benefit to the studio. So, like I said, you create a metal, it's going to look right everywhere. The method in which you create a metal or a non-metal is the same. It's always the same. There's no deviation from it. So it's consistent, and it means that you can just easily create materials that you need to create. So that's kind of like the overall benefit of PBR. What are the three main benefits to this? So with that, what we're going to do is we're going to discuss a very specific variant of PBR. Now, like I said before, PBR is like a standard, but it's a standard, but like I said, there's a lot of deviation from this standard. So for example, there are two main types of workflows that have basically emerged. You have what's considered metallic roughness, and the other one is called specular glossiness. And so both of these two workflows are working with the same data. They're both using the same values. It's just they're authored in maps differently. And so I remember this was about maybe 3 years ago when we at Algorithmic started trying to publish information about PBR, and a lot of people were trying to learn it. There was a lot of this question of, well, which one's better? Which one do I use? Which one do I not use? And both of them have pluses and minuses. There isn't like, oh, metallic's just better because of A, or, there's a lot of different, variation to that. Some studios choose metallic roughness, some choose spec gloss. Some studios will choose to do a mix of the two, and so on. And so what you end up getting is like you're basically working with the same data, but it starts to maybe be realized through the maps in different ways. And so that's, again, one of the things that we're going to really focus on in this class as we go through. If you can understand the theories behind what we're doing, then none of this will trip you up in the future. Like you'll know, like, oh, you'll be able to think in terms of spec gloss. You'll be able to think metal rough. You'll be able to create data for all kinds of different renderers because you know why these things are physically based and what those rules are. Then you can, like I said, you can make your maps for anywhere. So we're going to be talking about metallic roughness, and the reason is, and that's my personal workflow that I like to use. I rarely ever use spec gloss. The reason behind that is just because and this is one of the pluses of metallic roughness, is that it just seems to be the workflow that's adopted most places. So, for example, Unreal Engine is a really good example. Very, very popular engine. It's only metallic roughness. You can't even work in spec gloss in Unreal Engine. So there's one huge point. Another point is Unity. Unity supports both metallic roughness and specular glossiness, but they default to metallic roughness. So the default there is metallic roughness. And so here we go. We've got a question here right now. Will studios ever use a combination of spec gloss and metallic roughness on the same project? I don't know 100% to that. Now, I'll just tell you my experience of what I've seen. Now, I visited a lot of studios, which has been really cool part of working algorithmic. So every studio I've gone to, I have not seen that. I haven't seen a studio say, well, hey, on this same project, part of it's metal rough and part of it's spec gloss. I've never seen that. What I have seen is sometimes there's going to be a combination of the two. So they... And by that I mean, and I'll kind of hint on that when I talk about Unity here. So like I said, Unity supports both metal rough and spec gloss. But what they do in their metallic workflow is that instead of using metallic and roughness map, they'll use a metallic and a glossiness map, which they call smoothness. So that's when I remember when we were all first talking about this, that was so confusing because we were like, what do they do? What is smooth? But it's going back to these maps. And the data that's represented, it represents the same thing. So again, that core data never changes. You know what that data is. You can move back and forth between map types all day long and it won't affect you. So like, for example, some studios, there's one in particular, one of my favorite studios, one of my favorite AAA games. I guess I can't really mention it. I'm not sure, but I'll say it's an exclusive for Xbox. Well, we'll just say it's the Gears of War franchise. All right, I'm sorry if I don't know if I can. I'm sure they don't care, but it's just one of my favorite games. And when I visited that studio, I noticed that they were doing something similar to Unity, where even though they were an Unreal Engine, they were using, I think, smoothness instead of roughness. So really, smoothness is just the invert of a roughness map. So we'll talk about that more here in a bit when we actually talk about the roughness map. So just kind of a long, kind of roundabout explanation there about types. What we're focusing on, like I said, is going to be the metallic roughness workflow and its specific map types. And like I said, because most places I've seen, that's kind of what they default to. Okay, so with that said, we're going to talk about our first map type, which is base color. So base color in the metallic roughness workflow, what you have is you have a base color map, you have a roughness map, and you have a metallic map. Those are the three main maps. The other maps, like normal map and ambient occlusion, those are the same maps that you'll see in spec gloss as well. So what we're going to talk about is the base color, and we're going to talk about, like I said, roughness and metallic. So when we look at base color, what we're talking about is a map that represents two pieces of information. It represents what I like to say is it contains diffuse reflected color, which is sometimes referred to as albedo. And then it also contains metal color tint reflected light. Sometimes I'll call that metal reflectance value. So let's look at the albedo first. Let's think about that. So, and this is another term you'll hear quite often in different settings. So, well, what is albedo? A lot of times you might see that, or someone will reference that as raw color. What it really represents is diffuse reflected color. And I call that, or basically you can reference that, or best way to look at that, I think, is to think of it as color that we see. So basically, when light hits a surface and it reflects off, some wavelengths are absorbed and others are reflected back to our eye. And that color, that wavelength that's reflected back to our eye, that's what we see, or that's what our eyes interpret as color. So it's a huge simplification to what really happens with all that stuff. But that's the color that we see. So a really good example that I like to say, let's just say that you're holding like a red apple in your hand. So we see that as red. All the other wavelengths are absorbed. Red is reflected back to us, so we see that as red. So that's like the red skin of an apple. That's what diffuse reflected color. It's that reflected wavelength of color that's coming back to our eye. And it's that raw color. So a lot of times we'll see that as, like I said, albedo or diffuse reflected color. Another example is this. I'm sitting here working on a wood table. So this wood color, this kind of, it's like this brownish, tannish tint, what's coming back to me. That's, again, diffuse reflected color. Raw color or albedo, you'll hear that. And that is the value that's represented in your base color map. Now, that is the color for non-metals. Sometimes you'll hear this referred to as a dielectric. So that's a non-conductive material. And so that non-metal value is always going to be this diffuse reflective color. So dielectric, diffuse reflective color in the base color map. So that's the first piece of information. Now, there are some map guidelines to be aware of when we're talking about this albedo range. So one of the things that we talked about with PBR that's so important is, what we need these maps to be consistent. I talked about creating consistent artwork and looking correct in all lighting conditions. If you author the maps correctly, that will always be the case. And so when I talk about, authoring the maps correctly, we need to follow a few guidelines. So when we're talking about dielectric, or like I said, diffuse reflected color, we have these guidelines here. So number one for albedo, no lighting information. So going back to like the traditional shading workflow, one thing I used to always do is take like maybe ambient occlusion or some dark, something like that, and just multiply that into my base or my diffuse map. So that's a huge no-no. You don't want to do that anymore with physically based materials, because that is representing, like I said, we're thinking albedo, raw color, no lighting information. Another place this comes into play is that one of the things that I used to always do as well, or we all do, is, we go online and we look at texture libraries, and we might find, like, say we're trying to create like a wood table, and I might go and photograph some wood, a wood table that I see outside, or I might find, like I said, an image from my image library or something I find online. Well, if it's photographed like that, then you're going to see like lighting information in it. There's going to be some directional lighting. There's going to be some shadowing, stuff like that. All that information has to be removed for this to be physically correct. So there's a lot of tools that do that. For example, Substance has a tool called Bitmap to Material that does just that, where you can take an image that you photographed or something you found online, you run it through Bitmap to Material, and it will give you controls for removing this lighting information to create an albedo map. So good tool for that, real easy to use. But we want to catch that no lighting information. Very important. Now, I say that, but we could have some exceptions. So later we'll talk about ambient occlusion. Sometimes the ambient occlusion is fed into a PBR shader as a separate input to the shader. So a whole separate channel, ambient occlusion map, all of its own, gets plugged into there. But sometimes that may not be enough to really kick that ambient occlusion to get the look that you want. So sometimes I will take something, or you'll refer to something as micro occlusion. So some of that little bit of micro occlusion, like really small detail, maybe you could cheat a little bit and place that into the base color by multiplying it in. But you just need to make sure that you then, so we're almost breaking the rule here a little bit, but then if we follow these next two, we'll still be okay. So that's an exception. Sometimes you can maybe put some ambient occlusion, micro occlusion into there to kind of help kick that ambient occlusion that you have in your shader if you think that it's not working too great. Now, with that said, we've got this range here. We've got two ranges for dark and light values. So we have this range I like to call dark values, less than 30 sRGB, no dark values less than this. So when we look at materials in the real world, nothing is as dark as we expect. For example, I've got this Wacom pen case sitting here on my desk. I'm picking it up and I'm looking at it as black. It's a black case. Now, if I'm authoring this as a material, say I'm trying to make a texture for this, what I might think of doing is saying, oh, well, that's black, it's 000, But that's wrong. That's never the case. Nothing's ever black. If you look at something, one of the darkest materials that we have, like coal, we might look at a lump of coal and think, oh, coal, that as a element or a material, that's black. No, it's not. It's not actually black. Nothing in the real world is like pure black, because all kinds of other attributes and stuff. But we need to understand that we're not ever just using black and white values. So a good rule of thumb is to follow this dark values, no dark values less than 30 sRGB. And I'm talking about sRGB here because we're talking about a 0 to 255 scale here. is what we're talking about. So 0 to 255, that's typically where you're going to kind of author your materials if you're using, let's say, Substance, even though Substance Designer and Painter both can work in float values. UE4, if you're in that UE4 material editor, you can input float values. Photoshop, you can as well. But most of the time, it's easier just to work in this 0 to 255 range. I mean, it's kind of what we're all used to. And so that's considered sRGB, or gamma corrected space. More on that later. Just know that, okay, we're talking about 0 to 255. So if I'm going to make something that's like a dark value like this, like again, I'm picking up this kind of little Wacom pen case. And so I would say for black, I would just maybe do 30, 30, 30. I wouldn't ever go less than that. And that's, there's a strict range too, where some studios may say, no, we want it to be nothing less than 50. So like I said, that's pretty strict. I don't ever adhere to this. I just kind of stick in this 30 sRGB range. All right, so that kind of takes care of our dark value. It's a really good rule of thumb, not hard to do at all. We just know, hey, let's just not make our dark values too dark. So that's what we're talking about there, and we'll come back to this later. The next step we have here is this bright values. So what we want to do is, on the other hand of this, we have dark values, and we have bright values. So for the bright values, we want to make sure we don't go above, so no bright values greater than 240 sRGB. So again, thinking about our 0 to 255 scale, we don't want to go brighter than 240. So another example, if we look at like snow, let's just say it's like we're recreating a snow scene on a, outside on a sunny or even cloudy day. We might think, oh, it's snow, it's white, 255 all the way, it's pure white. But it's not. Snow, even something as bright as we would say snow, it's not pure white. Now, pure white meaning this diffuse reflected color value. Now, if we're taking into consideration like a reflectance, the specular value and how that's going to move towards 100% reflective at this glancing angle, again, we'll get into more of that later, then yeah, it's going to appear to go full white on our monitor. But that's not what we're talking about. We're talking about the diffuse reflected color, which is, again, that wavelength color that's coming back to our eye. And so we don't want to author those values greater than white. So then we basically have this simple formula here for our albedo map, which is going to be no dark values no dark values below 30, no bright values above 240. Simple as it can be. Now, the next piece of the puzzle here is we have this metal color tint, or what we can say is reflected light, or a metal reflectance value. Now, the metal color tint, again, it's still a color that we see. So, example, if we look at copper or gold, we're going to see like a color value. Now, what happens is that we have metals, and some metals absorb light at these different wavelengths. For example, gold absorbs blue light at high frequency into the visual spectrum, so it appears yellow as a result of this. Now, since the refracted light is absorbed, the color tint of the metals comes from the reflected light, and thus in our maps, we don't give metals a diffuse color. So we don't worry about this diffuse color. We're talking about this reflected light value is what we're thinking about. Now, this value is also authored in this base color map. Now, in this particular case, I don't have a metal, so let's go to the next slide here and take a look. Let's see here. Let me get over here to my slide. All right, so here in this case, we're going to be looking at, like I said, a metal. So here we have this kind of metal material, and what we're looking at here is just a 100% raw metal. And the guidelines that we can have for metal is that they're going to be in a range of 60 to 100% specular. I used to say 70 to 100%, but I kind of give myself a little bit of a padding range, 60 to 70%, all the way up to 100% specular. And here's this metal tint value that I'm talking about. So we have things like gold, silver, aluminum, iron, copper. And this is that color tint value. So like I said, this is since the refracted light is absorbed, the color tint of metals is coming from this reflected light. And that's what this value is going to represent for us, this reflected light. So for example, again, if we look at gold, you can see that gold has an sRGB value, and this is 255, 226, 155. There's an sRGB. Now, this isn't a value that I made up at all. This is key. This is where we're talking about. Remember in the very first slide, I talked about there being these measured values, these scientifically measured values. we don't make this stuff up, which is awesome. So now I like aluminum. I want to make aluminum. I know that it's this value. I don't have to guess it. I don't have to wonder what it is. Same thing with iron. This is what the value is. Now I got these off a chart that I trusted. So one of the pioneers of PBR, especially in the real-time world, Sebastian Lagarde, his blog is really, really great, and it helped me a great deal when I was learning PBR. And so he has some really nice posts on PBR. He published some of these charts from these measured values as they relate to, PBR and UE4 and so on. So that's where I pull all this information from. So I always like to make sure I give Sebastian Lagarde the credit for where I'm getting these values from. But again, that's not something I made up. I just, I was able to get them from an actual reputable source. So we don't have to worry about it. That's the great part. You'll also notice that all of these values that we're looking at, they're really bright. So there isn't like a dark value in here. And that's because, again, these reflected values, these reflected light values or metal reflectance values, they equate to this 60 to 100% specular. That's what we're trying to do. So here is the map, and you can see how bright it is, and this is the metal value. Now, if we look at it, this is the rendered material. Now, if you look at it, you're like, well it looks dark in here, and it looks really bright here. A lot of this has to do with the environment that's being reflected, the roughness map, which is, going to diffuse the light and so on. And like I said, again, the environment that this metal is reflecting. What makes metal look like metal really comes down to, well, you've got your metal tint, you have your roughness value, but then you have your metallic value, which is what we're going to talk about next, and then you have the environment that it's reflected in. So one of the things that I've seen a lot of times that trips people up is they'll make a metal and they'll say, well, it just doesn't look like metal, it just looks black. And that's because they don't have an environment to actually reflect. So if you just had like a default like gradient backdrop, like going from maybe dark to gray or light blue to darker blue, like a sky or something that might be a default environment in a game engine, then it's not really going to look very metal because there isn't an environment for it to reflect. So a minute ago, I was talking about, our base color map and there being these two pieces of information. We've got base color, which represents our albedo, and then it also represents our metal reflectance value that we're talking about here. So the question then becomes, how in the world does the shader know which part to use in this base color map? And that comes down to this metallic map that you see here. It's just a little swatch. So the metallic map is a separate map, and it's just a mask, basically. It's a grayscale map going from black to white, where black represents non-metal or a dielectric, and white represents metal. Now, you can see here, this is representing a full raw metal material. So the metallic map in this is pure white. So what this does, like say we're feeding this into some type of renderer or a shader, a PBR shader. What the shader does is it looks at this. It's gonna look at this metallic map and it's gonna say, oh, okay, well, this metallic map here has a white. So, okay, all of the areas in this metallic map that are white, it's going to go and look at those corresponding areas in the base color map, and then it's going to use those areas that match up with the white areas in the metallic map as the metal tint value. So that's where we're going to get that metal tint value from. Same thing with the base color. So if we go back to our base color, you can see the metallic map is going to equal black. So again, the shader says, it looks at the map and says, oh, okay, well, in the metallic map, this area is black. So it's almost, think about, you have your base color, and then if you were to like lay or do an overlay of the metallic map right over top of it, and wherever those black areas line up on the base color map, those are going to become, or what's referred to as albedo in the shader. And that's how it works. So the metallic map is just a simple black and white map. We're going to look at this in a more practical way in an application, so it'll make more sense. Right now we're just talking theory, but the metallic map is just pure black and white. So you can have grayscale values within that, though. So one of the things you can think about with this is, okay, well, what if, I have like, is it always just pure binary black and white? Well, it could be, depending on the material, but in the real world, it's not really like that, because if you think about it, you might have a metal, and then that metal could have some oxidation, so a little rust. So that rust needs to be accounted for in the metallic map. So for example, rust is not metal, it's a non-metal. So anywhere you have rust, then it needs to be more black in the metallic map. So you're just telling the shader these are the areas that I need you to look at this albedo value from. Another thing to think about is dirt. So say you have a metal and you put dirt over top of it. Well, then you might have a lot of really soft kind of transitional grayscale values where you almost have a mix of two materials. You have a metal and then you have this dirt on top. So it's kind of like this kind of blending of these two materials together. So then you might have a lot of real kind of, transitional grayscale values. Again, we'll look at all this in a very practical example in just a bit. But the key takeaway here is that you have your base color map. Let's go back. You have your base color. Dielectric diffuse reflected color is one piece of information. Dark values never go below 30 sRGB, and bright values never go above 240. Black in the metallic map. The base color also represents this metallic reflectance value, or these metal tints. These are going to be pretty bright. They're always going to be authored here based on some kind of scientifically measured value that you'll get. 60 to 100% specular. So again, these are going to be pretty bright values, and they're always represented as white in the metallic map. Another thing, talking about this base color, if you look at this diffuse, this doesn't have to be some scientifically measured value. This one could just be, okay, well, I've got some reference that I have, and I typically what I'll do is I'll just sample, like if it's wood table, I'll sample the color value right off that. It's not like a measured value. It's more perceptive in that case. Okay, so that takes care of our base color. So the next thing we want to talk about is this roughness map. And this roughness map is very, very important. It's one of the most important maps you're going to create in PBR. Now, the roughness map is a grayscale map, and it represents the microsurface detail of a surface, and that is what scatters light. So, for example, right here, let me just grab my little pen here. So here I've got this little surface. This is like represents a material, and it's all jaggedy and stuff like this. So this is like at a microscopic level of pretty much any surface, unless it's like super, super polished. You're going to see little imperfections. Like this could be a scratch right here. This could be like a dent. This could be like maybe, I don't know, like a piece of like a fingerprint, an oil or something, And what happens is, when these light rays come in like this, they come in, they're going to bounce off these surfaces. So here, that's what these green lines are. We're just bouncing off in all these different ways. And so the light that's coming in is going to get diffused and scattered in all these different ways. And that results in kind of a diffused highlight. So what happens with this is it appears that the reflection is softer or dimmer. In reality, though, the same amount of light is being reflected. So let's say that here we had... let's say that here we had a really smooth surface, and we had our light coming in, and it would hit, and it reflected off like this, like in a smooth surface, right? The same kind of incoming angle is going to be the same as this outgoing angle, and so this is going to look like a very, very like bright highlight here, really sharp, bright highlight. But as we diffuse it, and so again, it's a rough surface, and these lights being spread everywhere, it's going to look more diffuse, and it's going to make the highlight look more wide, and it's going to look dimmer, and so on. So that's one of the results that we get from this roughness map, and that's what we're authoring here in this roughness map, this microsurface detail. So we're not modeling this on the model; we're doing it based on this map. Now, within this case, the map is just a grayscale map, so rough equals white and smooth equals black. And anything in between is a variation between smooth and rough. Now, this roughness map is the most creative map that you can create. There are no rules here. You cannot mess this up. You cannot go wrong with this. It's completely up to what you want to do. But the thing about this map that's so important is that this map truly describes the full characteristic of the material. For example, with the roughness map, you can see in this example, we've got this gray value, we've got these black scratch marks in here, which is going to equal kind of a smoother, brighter highlight. So you're going to see like maybe some specular hits off this and so on. A lot of variation. You want to add things like scratches, fingerprints, all this kind of stuff. And I like to think of it as the roughness really kind of tells the story of the material you're trying to create. Think of it like this. I mean, like if you look at the roughness, it's gonna tell you things like, well, how was this material handled? Or let's say, how was this surface handled? Was it handled with care? Was it handled roughly? Is there a lot of dents and scratches all over it? Is there a lot of fingerprints? Is there grease marks? Is there food stain? I mean, you can on and on and on. What is there oxidation all over it? Is there, was it just left out in the rain? Was it cared for? All this kind of stuff. So you could tell, think about your material as a character in a story. When you're creating a render or you're creating an image, the material itself is a character as well. It's not just the object, it's the material that really tells you what it is. The roughness gives you that tactile feel that we have with our senses. We see things with our eyes. We interpret things when we touch and feel them. All that's in the roughness map. And like I said, it's the king map. It's the most creative map that we have as artists. And the more detail and the more variation you put in this roughness map, the more realistic the surface is going to look. So that's the roughness map. Like I said, can't go wrong with it. One of the things I want to do with this, though, let me jump over here to Substance Painter, and I'm just going to use this as a way to kind of demonstrate something. So let's talk about that roughness information. So if we come over here, I'm just going to create like a simple fill layer here, and let me make sure these shadows are off. Okay, so this is a fill layer, and I'm going to make this a metallic surface. And you can see I've got a pretty bright value here for this metal reflectance value, and it's a pure metal. So if we look really quick at our channels, just as an overcap, base color, this is going to be our metal reflectance. So what happens is the shader looks at this and says, oh, this is my metallic map. As you can see here, it's pure white. So it says, okay, well then all of these values here in this base color represent metal reflectance value. And then here, if we look at our roughness, we can see that we've got, a value like this here. So with our environment, I'm just moving my light around. If I make this really smooth, so a pure black, pure black, really smooth. Now, right now I have, let me turn that off here. Okay. So there was some normal data information in this group that was also kind of breaking up the light a bit. So again, normal data also representing kind of our surface attribute, like kind of the surface variation. So again, it kind of plays in with the normal map. Normal map is done, like I said, describing that microsurface. So I've just disabled that for now. So here you can see at black, we get a perfect mirror. Okay, so I'm moving my light around. Here's like a highlight area. It's just like a perfect mirror. But as we start to increase this roughness value towards black, you can see these highlights, they're starting to diffuse a bit more. Here, let me try something else. Let me go into my environments. And let me just set a different environment, just because I think I might be able to, where is this guy? Glazed patio. Let me try. Oops. All right, let's try this guy here. All right, so let's go back to our roughness. All right, so here we have the sun reflecting in here, and we've got a pretty, sharper highlight here based on this environment map, okay? And so, like I said, it's pure mirror. If we look, we can see all these clouds and everything like that in here. And then we see the sun, and this is the highlight that we get. Now, as we start to increase this roughness value, you'll notice that this highlight starts to spread like this. So it's spreading, it's getting bigger and bigger and bigger and bigger. And then as we start to get more and more rough, you'll notice that now the highlight starts to look dim. So here it is really spread, and we start to increase it. Now the highlight appears to be getting smaller and dimmer and darker and darker and darker. Now here we are full rough. Now at this value, and it depends on the algorithm. So here, let me not do full rough. Like at 1, you'll probably never ever use that value. So let me do something close enough to this. So like I said, this looks like a really dark surface. The same amount of light is being reflected as we see here. So if I look at it here versus here, same amount of light's being reflected. The only difference is that the light is being bumped and diffused. So even though if we look at this geometry, the geometry is perfectly smooth. But what we're simulating here with this roughness map, we're simulating this micro surface. So again, it goes back to, where is this guy here? Whoops, hold on a second. There we go. It simulates this kind of rough surface. So what we're doing with that roughness map is simulating kind of these porous kind of microsurface details that's scattering this light, even though the geometry itself is perfectly smooth. So that's why we scatter this light, so much here. But the same amount of light's being reflected. We're not like losing light. It's just being diffused a great deal. And so here's what we get here. All right, so let me just disable this guy, and I'll put this back here for now. All right, so let's jump back over here to our PowerPoint and just keep talking about some of this theory. And we're going to walk through a lot more of this in a more practical sense. Again, I'll use Painter's viewport to explain all this, but right now this is just kind of theory stuff. All right, so the next thing that we have here is we got a roughness. Now, this one here is talking about specular, and I'm just going to talk about it because it's very specific to the metallic roughness workflow. Now, you won't see this in specular gloss at all. So sometimes you might look at a PBR shader and you might see a specular channel. So I say this because in UE4, we see this a lot, and I see a lot of confusion when it comes to this specular channel. So we have this specular channel in UE4. And I see a lot of people trying to input data into that like they're creating a specular map. And what that actually represents is not a specular map data at all. It's completely different than what you would expect. And I like to describe this slide because it really also details something very specific about the metallic roughness workflow. Okay, so we had just been talking about metal reflectance values. Let me just go back a slide here. So metal tint, and remember I was talking about in our metal values, 60 to 100% specular, and we are authoring this 60 to 100% specular value in the base color. So that's what these bright metal, these bright color values are. Okay, that makes sense for metal, but you may be asking yourself, well, what about when I have diffuse reflected color or the albedo? How do I make that reflective, or how is that determined? Where's the reflective value? Because so far I haven't mentioned that at all. Well, the actual case is that you can't mess with it. That's one of the things about the metallic roughness workflow. It's hard-coded in the shader. You can't change it. It's just locked at a specific value. So if we go back here to this specular channel and talk about this, when I said it's locked, it's locked at what's considered this F0 value here. So here, let me actually change this color on this guy. It's locked at what we call this F0 value. So what this means is Fresnel at 0 angle or 0 degrees. And so you'll hear a lot about, Fresnel and, fall off, those kind of things for those reflectance values. The great thing about PBR, again, is that we do not have to worry about it. So the Fresnel is actually part of the BRDF, which is, again, all hard-coded in the shader. And so PBR, typically, most every PBR, it wasn't that way at the beginning. Most every PBR implementation was using GGX. And that's based on Disney's principled shader that they developed. And everybody basically just kind of mimicked that with a couple variations here and there. Unity was a good example. Like when when Unity 5 first came out, they weren't using GGX. And so you were getting a lot of discrepancies between Substance and Unity or any other program that you were working in Unity. They have since... and early on after that, they switched to GGX. So GGX is a BRDF, explains all kinds of scientific stuff about Fresnel and all that kind of information. Again, we don't have to worry about it, which is awesome because it's just in the shader. I don't have to create Fresnel nodes and do all this kind of stuff. But it's very helpful to understand what's happening under the hood, as with anything, because once you understand it, then you can know what to do if you need to break the rules, basically. So, like I said, we've got this specular channel in UE4. What it represents is this Fresnel at 0 angle. So when you have a Fresnel, you have 0, and then you have here a 90 degrees. And so this Fresnel angle this value is gonna change. So you're gonna have a reflectance value at 0, and then you're gonna have a value at 90-degree angle. So 0, this is like us looking, like you're holding, like if I had this ball in my hand and I'm looking straight at it, That's that 0 angle. And then the glancing or the grazing angle, which I'm talking about here, is that as that angle moves towards 90 off to the side, which you see here, it's going to move to be 100% specular. So PBR just hard codes that into to the shader. Everything is going to go 100% specular at this grazing angle. Even though it may not appear that way, like I showed you in Substance Painter just a minute ago, as we increase that roughness value all the way, to extremely rough, it looks very, very diffused on the edges, but we're still reflecting the same amount of light. It's just diffused so much. Now, sometimes different shaders, depending on how their algorithm is written, if you give it a value of 1, it may not actually go to this 100. I'm not really sure. I think there's some issues here and there with that. But again, most of the time, you're not ever going to put, a pure 100% reflect or white value in your reference map anyways. It's always very well varied. So like I said, we got 0 to 90. Well, 90 is easy. We know what this is. It's 100%. Done. Nothing to worry about there. Now, what's the value at this F0 value? What's that? Well, it's hard-coded in the shader to be 4%. So 4% reflective. That means any non-metal that you create when you're working in a PBR shader that's using metallic rough and spec gloss. Spec gloss is the same. Actually, scratch that. I'll come back to that in just a second. Again, we're not talking about spec gloss, but I want to make a point so you understand. So metallic roughness, it's always hard-coded as 4% reflective at this Fresnel 0 angle. So we know that value. We most of the time can't change that. The reason that is because most common dielectrics fall right in that 4% range. Like if you look at concrete, wood, dirt, grass, whatever it is, it's most common dielectric non-metal materials are 4%. And the value between these different materials vary slightly. So even if you did change it, it's such a small change that you wouldn't maybe even perceive it with the eye. So it's almost like it doesn't matter. So that's why the shader's just like, yeah, just do 4% for everything. It'll work. Now, with that said, there are some exceptions. Like if you were going to try to make gemstones, those are not 4%. They're closer to like 8%. So it's a non-metal, but we want to be able to represent everything. So we've got to have a way to override this 4% value if we need to. And so that's why, like in applications like UE4, you'll see the specular channel. We also have that inside of Substance Designer, a specular level. So it just gives you a way to override this hard-coded 4% value at this 0 angle. So it's, like I said, it's very important that you understand that by default you're working with 4%, and most 95% of the time it works. You don't have to need it. Now, like I said, common dielectrics, it's 4% is kind of the standard, but they will vary from 2 to 5%. They could. 2 to 5% common dielectrics. Now, if we look at this, I've got this little chart here that lets just see these common dielectrics. So if we look at 2, it's kind of a darker gray, and then 5, it's a little lighter gray. The difference between these values, it's very slight. Look at 4% to 5%. Is it even worth going through the trouble of trying to author that? I don't think so. When I talk to, there are some people who do think there is a huge difference, and that's perfectly fine as well. I just kind of subscribe to it's good enough, 4% works. If you even look at UE4's documentation, they'll even tell you in that specular channel, don't really mess with this. So it's funny, even in their documentation, they'll tell you don't mess with it. I talked to our chief scientist at Algorithmic about this when we were creating the PBR guides and all this kind of stuff. And the insight they gave me as well was the same. Like, it varies so slightly, you're not going to see a difference, especially when you're going to layer roughness over top of it. So you're going to have a specular value, then you're going to have roughness, which is breaking everything up. Are you really going to see the difference between these two things? Probably not. Maybe where this really kind of, in my opinion, is more of an impact is if you're an ArcViz. If you're an ArcViz, then yeah, maybe so. But in our case, 4% works for almost everything. And like I said, the variation between 2 to 5 is so slight, it's not even worth the change, really. So you now know that we have this hard-coded 4% value, and the shader automatically applies 4%, and then it goes to 100%. We don't have to do any of that. All hard-coded in the shader, none of our business to worry about, which is awesome. Okay, so like I said, we can now override that. So when you look at this, these shaders like UE4 and Substance Designer, there's a specific range that that specular channel and level input. So it only goes from 0 to 1. And what UE4 and Substance Designer does is it says, okay, I'm going to take a range of 0 and 8%, and I'm going to remap this value to 0 and 1.0. So actually, that's might be hard to see here. Is it? Let's say 1.0. Maybe this is better. So 0.0 and 8%. So it basically takes this range of 0 to 8 and remaps it. So where you have this 4% is really 0.5 is what it looks like. So if you were inside of UE4 and you wanted to say, all right, I want to override this F0 value so that it equals like 2%, you would use a constant float value of maybe something like 0.2 or something like that. I don't know. Like if 0.5 is 4, it looks like it could be right. Maybe 5% is 0.6, and then you've got 0.89, and then at 1 you're looking at 8%. So it goes from, again, it just remaps 0 to 8% to 0 to 1. UE4 does this, and so does Substance Designer. So just to give you an idea of how that works, let me just kind of demonstrate this really quick. So let me just switch into Substance Designer, and let me turn this guy off. So really quick, what I'm going to do here is, let me just add a base material here. All right, so we had, let's see, whoops, let me get rid of that. We have one question coming here. With spec gloss workflow, you can manipulate spec color to create an fluorescent appearing material. Does metal rough workflow have an equivalent? Okay, so just thinking about that question, one step that I want to do before I answer that one is, you could, with spec gloss, like when I say that value is hard-coded inside of metallic roughness, spec gloss, it does not have that value hard-coded because you actually have a specular map. And in the specular map, you have to author the reflectance value for the non-metal and that metal reflectance value for the metal, all in that specular map. So you would have to know to say, all right, I'm going to make this correct. It needs to be 4%, and you have to do that. One of the reasons why sometimes specular gloss isn't used as much is because it's kind of, and I've heard this from many studios, it's kind of error prone, user error prone, because it gives the artist more flexibility, which means they could, put in a wrong value for a specular that's non-metal that isn't realistic. And it may look great in one scene, but it's not going to work great in another scene. It means you can't create these reusable assets. So in terms of creating a pearlescent appearing material, yeah, metal rough, it's going to have the same type of process. Not 100% sure. I haven't actually done that yet. So that could be something I might try to address afterwards. Or what I could do inside the Discord is maybe post more of a better solution to that for you guys later. I don't have something right off the top of my head to kind of demonstrate how that would be done. But yes, there's definitely going to be an equivalent. There isn't something you can do in spec gloss that you can't do in metal rough. So like I said, it's always the same data. It's just how the data is represented in different maps is really all it is. Like spec gloss gives you a little bit more freedom in the map because you can author that F0 value, but there is the chance that you could put wrong values in too. So that's one option. So yeah, I'm trying to keep myself kind of aware of the schedules and everything. So let me try to be quick about this. If we had this base material here and I plug this guy in. Okay, so let me set this here to be like a dielectric. And I'm just going to choose like a value. And then here I've got like this roughness value here. Okay, so let me come into this map here. And okay, so this guy doesn't actually have a specular input field to it. So what I'm going to do is just create a uniform color, set it to grayscale. It's a float value, so it's 0 to 1. And I'll set it to 0.5. So we know that that's going to represent 4% because we're talking 0 to 8% is remapped to that 0 to 1. And let me just right click and drag and drop this into my shader view and set this manually to specular level. So when I do that, you'll see, well, there's no change. Nothing happened because it's at that specular value. So as I start to change this, you can see, the difference that we're getting here. So as I set this up to say something like 1, I'm really setting this dielectric to be 8% at F0. So we start to get maybe a little brighter highlight, or we could have something at 0. This is like basically air, so this isn't going to work for us. But if we do something like maybe 0.25, so there's a difference between this and this is, here, let's just set it to like 0.2, and we're thinking maybe this is like 2%, and then here is 4%. So it just looks like a brighter highlight. But once we go into here and we start to like layer in roughness information on top of this, so say I come in and I add some grunge amount into this, just set a value like this. Now, when I start to make these changes, it's a lot less apparent. But it's basically just a control of almost just kind of brightening that specular value based on that. So it can make a difference, but like I said, most of the time you really don't need to worry about it. Okay, so going back to our PowerPoint, that takes care of what that F0 value is. And like I said, now that you know what that is, it makes it a lot easier to work with things like, UE4 Designer if we need to override that, or if you're working in Spec Gloss, you need to, work on that, is you can know that you're going to author that F0 value in that specular map. Okay, so like I said, this kind of wraps up with the key factors of PBR being energy conservation. That's, there's never going to be, more light reflected. Basically, it means the light coming in is going to be the same amount of light going out. So we're never going to like have, an intensity value coming in, and then it gets reflected, and then it's even more intense going out. So that's not going to ever happen in the real world. So we have this kind of concept of energy conservation that happens in the real world, and that the PBR shaders are mimicking this. Again, handled by shader, we don't need to worry about it. Fresnel, the BRDF handled by the shader. Again, we don't have to worry about it. So specular intensity, it's controlled through the BRDF, which is, we don't have to worry about it. Our roughness map, which we saw earlier when I was in Painter, and I was moving that roughness slider up and down, and the more rough, the more kind of diffused, darker, dimmer the highlight looked. And that F0 reflectance value in our specular. Again, going back, the result is if I start to change this, it just looks like the intensity value for that specular highlight's changing. So it's controlling that. So those are the 3 ways that we control that. Really, if you look at it, roughness is 95% of the time what you're going to be checking with. And then finally, the lighting calculations are all computed in linear space. We could have an entire course on linear space rendering all on its own, so we don't want to get too crazy into it. Like I said, we're getting close to an hour, but I still got more to show you guys, so hopefully it's okay if I go over a little bit. I'm sorry, I try to keep everybody's time in check. I know that you guys you don't want to hear me talk for too long. But lighting calculations all computed in linear space. So that's very important when it comes to understanding how maps need to be interpreted. So with that, I have this last slide here, and then we're going to get into a kind of a practical look at something. This is UE4, so map interpretation needs to be set correctly. Here you can see that I've got, this is like a metallic map, and so you can see it, well, white we know is metallic and black is non-metal, but you have like these gray values, so this is representing like probably dirt or something like that on top of it. So we get this transitional value. Now, this map interpretation here, this metallic map, this data equals linear, okay? So this is what I refer to as a data map. It's not color, it's data. So again, it's not color that we see. So we need to tell the system, whatever renderer this is, that, hey, this map represents data. So you'll notice in UE4, there's this sRGB button when you open up in the texture editor. And by default, it's enabled, it's checked. So on maps like metallic, roughness, ambient occlusion, you want to take this sRGB and uncheck it, because you're just saying to the system, hey, I want you to treat this map as linear, or this represents data. Now, one of these questions that I used to get a lot, because people they were like, wait a minute, this is PBR, we're talking about linear. Do we have to author these maps in linear space? No, you do not. That would be terrible to have to do that, because we don't see things in linear space. Our monitors don't work in linear space. So it would be really terrible for us to do that. There's no reason to ever try to author these maps in linear space. Just author them in gamma space, which is sRGB, because that's how we see, that's how our monitors are all calibrated. That's just what it does. So even though we authored this in gamma space, it represents data. So we tell the system, hey, UE4, don't try to remove the gamma encoded values in this. I want you to treat these values as is. So sRGB unchecked. Now, if it's a map that represents color that we see, that's going to be that's going to be, well, our base color if we're talking about metallic roughness, base color. If you're looking at specular glossiness, it would be a diffuse and specular map. Those are color that we see. Again, that's diffuse reflected color and that metal reflectance value, that metal tint color. That's color that's reflected back to our eye. So we authored that color in a gamma encoded space, which is our monitor, and we viewed it with our gamma encoded eyes. So we need to tell the system, hey, that's sRGB. So this would be checked. And what happens is the shader internally will then linearize that data. It basically will apply an inverse gamma, 0.4545, and it will reverse it so that the linear computation works correctly, because in the end, all the lighting is calculated in linear math space, and then it's viewed in our monitor in gamma space, so it looks right to us. A lot of stuff to have to worry about. We don't care. All we have to know is make sure we do our map interpretation correctly. So to give you an example, a practical example of that, this is a character that I've been working on in Maya, and I did all the painting inside of Substance Painter. So again, I just export the maps. I'm not worrying about gammas. I'm not trying to do anything in linear space. But when I actually go to my material setup, so let's look at let me look at the shoulder padding, because there is roughness map in here. No, I'm sorry. Let me go to the attachment, because there's a metallic map in here. At least there should be. Yeah. All right. So you'll notice here, and I'm talking about this kind of shoulder pad, this metal. So it's metal. There's dirt and there's stuff on it. So you can see that this is my base color. If I look at the color space in Maya, sRGB. Here is my roughness map. Color space is set to raw. So that's how you do it in Maya. You just set it to raw. Like I said, in UE4, you would uncheck sRGB. In Substance, it does it all automatically. It knows what to do, so you don't have to worry about it. But here you can see I'm just setting my map to interpret correctly. You don't author the maps in linear space. You just interpret them correctly. You have to do this in pretty much every renderer. So roughness set to raw. Here's my metallic map. Again, it represents data, so I tell the color space raw. Now your normal map, in case you were wondering, even though it's an RGB image, it represents data, so color space would always be raw. Like in UE4, it does it on its own because it represents as a normal map or whatever it does. But like in Maya, you would set color space to raw. So here you can see I don't have to be an expert in linear space rendering. I just have to know simple. If it's a color map, it needs to be sRGB. If it's a data map, it needs to be raw. Okay, so that takes care of kind of this setting here. Now, the last stage I wanted to do was kind of just, let's take all this stuff we learned and just look at like an actual example of stuff that we can do. So this is the sample project that I have here in Substance Painter. Let me just switch this back to this panorama image here that's just kind of more basic in the lighting. Well, sorry about this, guys. Let me take a step back. One other thing I want to talk about, and this is more referred to UE4, or this is in UE4 that I'm talking about, but this matters in everything that you do when it comes to PBR. So if you're you want to light this with some type of HDR map. So you're going to have an HDR cube map, or some type of lighting information like that. Because you want to make sure that your metals and everything has the appropriate environment to reflect. Because if you don't, it's just going to look black. You're going to look at the metal, it's going to look black. So here you can see, that we have this specified cube map here in UE4. I'm using Glazed Patio. This is just one of the HDR maps that ship with Painter or Designer, and that's what I use. Here inside of Maya, I'm using Arnold to do the rendering. And so here's my Skydome light. Let's look at the attribute editor. You can see I'm just using Arnold Skydome. And then for the color intensity value, here I'm just using panorama map.hdr. Again, I pulled this from Substance Designer resources. So again, it's just this HDR map that I'm using here for the background. Yeah, so I see a couple notes here about get triggered when it pulled up Maya. I don't know if you guys are like Maya or don't, But yeah, I use Maya, Moto, Max. You got to use them all. And what's interesting is you'll see it's all the same setup no matter what 3D program you guys are teaching or using. And I will say, like, the more of these programs that you are familiar with and the better it is too. So like but it isn't really so much about a 3D programs per se. It's really about the knowledge that which is good. So like, if you, like I said, this is all about just trying to understand what this is doing. So like, I don't know 3ds Max very well, but I know that if I just set up 3ds Max to do testing or rendering, it's really easy now. It's easier for me to just jump in and know what I need to do. Like I know, oh, okay, I'm going to create an environment map because I need something to reflect. I need to come over here in my material, and I know that my maps need to be interpreted correctly. See, I know all that stuff, and it just comes a matter of, here, let me look up how to do that in 3ds Max, which is simple, but it's not like, the rendering part of it's changing dramatically. Okay, so let's see here. Oh, yeah, going back to Painter here. So like I said, in my environment map, if we just open it up, here's this environment that let me just take the blur off. So here I'm just using an environment is what we're looking at here. Okay, so this is like a material here that we have in place. And what I wanted to do was just kind of demonstrate some of these principles. So this guy here has got a base. Here it's got dirt. If I look at the dirt map, so here we've got some dirt on top. Is a material. This is the mask that's creating this dirt. If we look at our edge damages, it's got some edge wear. So here's the mask that's creating this edge wear and so on. And if we look at our maps, we can see here, this is base color. So it's, again, this is albedo or the raw color. Well, we don't have any height. Here's the roughness. Now look at the roughness map. There's all this detail in it. The included areas, you can see here all the included areas where maybe a lot of dirt and dust and grime and grit is kind of would collect. That's going to be more white, more rough. So it's going to include more of this light. And then you can see that area here that represents that edge damage. So again, just to kind of show you what that was. Here's that mask that shows that edge damage where it's like the metal paint's getting, or that paint's getting chipped off and revealing some raw metal. It's going to be more bright. So if we look at the roughness for that area, it's darker, which means it's going to be more shiny and so on. And then here we've got scratches, little crack lines, all this kind of stuff. So a lot of intricate detail to create this. Here's the metallic map. So the metallic map, you can see, white everywhere where there's metal. And then in areas where all that dirt and grime was, it's black. So that means that that's basically going to be, that means that, that's going to be non-metal. It's a non-metal area. So what I want to show you guys, we're going to do two examples. So the first thing I want to show you is a tool that kind of helps with understanding this. So I've got this tool called the Metal Rough Validate, and you can actually grab this on Substance Share. So once you add this into your Painter project, you could just left click and drag and drop this guy here to the top of the layer stack. And it's going to render basically this gradient over top of everything. And this is going to, show me some information. So validation mode, albedo. So it's looking at just the albedo texture, which is in our case is going to be base color. So it's looking at that base color map. And what it does is it looks at the metallic map and it says, okay, everywhere that I have black in this metallic map. So see here this black, it knows that, okay, that means that that's going to be albedo. So then, right, we have this black area. It goes over to the base color. Oh, sorry, I gotta disable that. It goes over to the base color and it looks at this value. So remember, our base color for albedo, we need to make sure that we don't fall below a threshold of 30 sRGB. So it makes sure that this value is not too dark. Okay, so right now, if we view this, the validator's green and it's saying, hey, well, I got a little bit of red here and there, but for the most part, this tells me that, well, albedo-wise, this is good. No problems. So let's look at what would happen if I come into this dirt here. And let's see, not the dirt. What do I want to do with this guy? Hold on a second. Where is this guy coming in? Ah, okay. So it was set to black. Okay. I didn't actually create this material, so I'm not trying to figure it out as I go. But this is cool for you guys to see this. So I'm looking at this and I'm thinking, oh, what? It's black. That's wrong, right? But if you'll look at what they've done for base colors opacity, it's lowered. So it gives me the result of it not being a pure black value So that looks more brown. It's not black because we've lowered that opacity. So what happens though if I set this value to be more black? Now it looks red. So this is showing me that the albedo is incorrect. That means that I'm using black. So if I wanted to lift this value, watch, as I start to lift this from black, it starts to change. It's going yellow, and now we are corrected at this range. Now these values in Painter, it's a little confusing because these are all in linear. So the color picker is sRGB space, but these values, if you enter, you can't enter like sRGB values into here, which I find to be pretty confusing because you'd have to like take the sRGB value and then you'd have to, convert that to linear and then enter the value. So that's why you're looking at this at 0.086. It's the linear value of this. So now it looks correct. So if I turn this guy off and I look at my map, this is what it is. All right. So, but again, we didn't want it to be, this color, black. So here, this would be a value where I might come in and try to set it like something more like this. So what the author in this case did, so notice instead of just changing it this way, they set it to pure black. Now you can see this looks totally bad. And then they just set the opacity value to this. So now we can look at this and say, oh, okay, that's all green. It's good. We're good to go. All right, so now let's look at another variation of this. If I were to look at this as my metal, we have a problem. So as soon as I switch this into metal mode, I have this range here called the metal reflectance range. And this is set to be 60 to 100, or you have 70. So like I said, I typically just look at it at 60 to 70. And if we overlay our map, we can see here the areas where this is the green areas are showing where this is going to be messed up, basically. Or I'm sorry, the red areas are showing where this is going to be messed up. So if we come back here to this base metal value, you can see that what we actually have here is something that's a little bit incorrect for this material. So we have told this material to be 100% metallic. So if I look at this guy, white for this metallic map, which means, again, this base color value should be, or it should equate to a color tint value that would be like 60 to 100%, 60 to 100% specular, so it should be brighter than this. So this is actually kind of incorrect. So what I could do is I'll use this guy here and I'll come into this base color value and I'll just start to lift this. And as I lift it, now you can see it turned green. So I just lifted that value and now this is actually corrected. So what I had was a metal reflectance value that was too low. It wasn't in that 60 to 70% range. So this is actually more of a corrected type material. All right, so like I said, guys, sorry, it's 3:12. I'm trying to keep this quick. I got one more thing to show you guys. I just want to work through this example in another way just to show you some stuff, and then I'll wrap it up. Okay, so let's do this. Let's just create a material now really quickly. So one of the things I'm going to do is, let's see, what could I do? I'm going to create like a fill layer here, and this is going to be like a metal. All right, and I'm going to set it to be 100% metal, so I get something like this, and then I've got a base color value, kind of a brighter value like this. So here we go. We got this. Now, another thing I like to do is I come into my roughness. I'm just going to grab a grunge map really quick, and I'm going to grab maybe this map here. And maybe change my projection and tile it. Well, no, I don't want to tile it. We'll do something like this. So that's pretty rough values. I don't really like that. So one thing I could do, or one thing I do often is just to come into here, add a levels, and set my roughness, and then I just kind of tweak it like this. Oops. So it's just a slight roughness value. So if I zoom in kind of close, you can see it's just, it's just giving me some nice detail there. All right. So there's our metal value here. And then what I'm going to do on this guy here is I'm going to start to, this is basically a raw metal at this stage. So here, let's take a look at what I have for my settings. Oh, okay, good. If I look at my rough validate node under metal, I know that my metal reflectance value is okay for this pure metal. So we're good to go. So the next thing I'm going to do is simulate the idea of, well, what if I add some dirt on top of this? So now we're going to add another fill layer. This one here is going to be like, say, dirt. And my metal value is going to be, well, here, we'll mess with this metal value in a little bit. But let's just create something like a dark value like this. And I want this to be pretty rough. So this is like a dirt layer. And I'm going to mask this and just quickly use a generator for dirt just to get some dirt on here. So we'll do something like this. So this adds dirt really quickly for me in all these different areas, mainly in the occluded areas. And then I can, increase my contrast on this if I need to. So we'll do something like this. Okay, so now let's take a look at what we have. So at this stage, if we look at our dirt, and what I've done, it's correct so far, because if I look at my metallic map, you can see the dirt is inside the metallic map. So now we get these kind of gray kind of transitional values where we get like a metal and then another material, which is our dirt. So this dirt here, if you look, it's a full material. It has base color, roughness, metal. It has all these channels. It represents a full material. And it's just in here as well. And it's inside this metallic map. You'll notice that I set it to be metallic black. So here is where we get it. Now, inside of my mask, if I click my mask, you can see it has some transitional values. So it's basically saying in these occluded areas, we're going to be pretty much black in our metal. And you can see if I look at my metal map, it's black. So this gives me, as we can see in this mode, a correct result. Now, that's because in this material, I had set this metallic value to be black. What if I left it at 1? This is what I would this is what I would have. And sometimes people see this and they'll leave it like this. And if we look at this, we now see a really bad result because we did not account for this dirt in our metallic map. And again, if we look at our metallic map, whoops, passed it right up, it's pure white. So we have no dirt in this. So like I said, we want to account for this. Now, sometimes since we have some of this kind of transitional gray values like this, we could even just maybe we want some of that metal to kind of peek through. So here, let's do this. Let's go into our material mode and let's take this metal value and let's cheat it a little bit and come up to like maybe here. Something like that. All right, so now we get something more in kind of this kind of look. So I gave it a little bit of a metallic look. Now we'll go back to our base color. Oh, we're still good because it was only a slight change. As we start to increase this up is when we'll start to see this change for us. Yeah, see? Now, the reason why it takes so much of this to come metal, so I could actually bring it down to more about this range, is because, again, in this particular case, this mask that I created, it's very, very kind of, there's a lot of grayscale values in that. So again, we just need to account for the dirt within that. So another thing that we could do that I like to point out is, let's say that I have this metal here and I want it to be like a painted metal, or a darker metal. So sometimes people will do this. I'll see they'll come in and say, oh, okay, this is a pure metal, but I want it to be like a dark metal like this. So if we look, you'll think, oh, here's this kind of dark metal value like this. If we look physically, this is completely wrong because the base color, that metal reflectance value, even though I told this metal mask to be pure white in that base color map, whoops, passed it up. It's a too dark of a value, meaning that it doesn't equate to the 60% reflective. So that's why we get, this. But I'll see this happen a lot. So here's kind of the way I handle this. So one thing I may do with this typically is I will have maybe, what we're trying to create here is just a coated metal. So you have like a metal and it might have a paint layer or it might be have a coated, like a coating on top that's not actually metal. It's another kind of like element coated on top of it. So what I'll do for that is like this could be like the raw metal here, which would be, this is going to have like a brighter value. And then maybe I'll duplicate this layer here, and this is going to be the coating layer. So I'll keep this, and this will be the coating. And in this case of the coating, I don't need my height, I don't need roughness, I don't need normal. It's just, it's taking care of everything. But my metal value, I'm going to decrease it. to maybe something like this. And you can watch this little thumbnail. You can watch it change. There we go. It's starting to update. There we go. So now I've got kind of like this coated metal here. And what I might want to do is do this and then just come back to this base color value, maybe make this even darker or something like this. So now this would work as this metal here for this coating on top of it. And if we look, we're still green in here because our metal in our metal map is going to be correct. Here's our metal map now. Notice that it's not pure white. It's slightly white, you know, so it's like, you know, we're getting into this stage of kind of mixing how these materials are working, and so on. So this is another way I'll kind of work sometimes to get a metal that's kind of coated like this. So this is going to work for me physically based. It's going to be consistent, I'll say, as I work. Another way I might do that would be just to come into my metal. If I wanted that to be coated, I would drop my value here, but then I would just come over to my metallic and just do something like that. So here you can see I'm just lowering that metallic value, but we're still okay here. So this will work. The reason why I kind of do it this other way with the coating is because a lot of times you may want to come into here. So if we do a black mask and then add a generator and do like, you know, edge wear. Whoops, let me just invert it. We may want to do something like this where now if we adjust our edge wear, we've got like the coatings being scraped away and revealing kind of that raw metal underneath of it. Again, if we look, we're all good everywhere. And then if we look at our metallic map now, it looks more like this, where we've got white, where it's pure raw metal, and then it's a bit darker. So even in here, what we could do is maybe come back to this coating and drop this guy down, something more like this maybe. Typically, I won't keep it up this high. So I'll keep it more like this, and then maybe I'll just darken this value like this. So that's kind of me creating like a metal with coating and then still trying to keep everything physically correct. So that's what I'm talking about. This kind of just wraps up everything here at the end, is that, you know, we're talking about understanding that whole theory behind everything we discussed in the beginning. You know, those the bright darkness, the bright and dark value ranges, or those tonal ranges of our albedo, that 60 to 100% reflectance range for those metal tints, being able to, you know, account for things like oxidation, rust, dirt, you know, all that kind of stuff inside of our metal map when we're trying to mix these materials and so on. So, you know, that's really kind of, once you know all that stuff and we're kind of putting all this into practice here at the end, you can see that knowing that information and how it all comes together allows you, when you're actually working, to create the type of materials that you want, and make sure that in the end they stay physically correct. So there we go. That is going to finally come to an end. Everything I had originally planned for 1 hour, but we went over 22 minutes. So I hope that's okay with everybody. I think it's kind of later for you guys than it is me. So I apologize for taking too much time. I hope you guys found this to be an interesting webinar. I hope that you guys learned. You know, kind of learned what you needed to. Also, I'll point out that on our website, if you go to algorithmic.com and you go to the Learn section, we have the PBR guide, which is a PDF. It's a 2-volume PDF. One of it's just total theory, and the other one is all practical map guidelines. Goes into more detail, all the stuff we covered in this webinar here. So again, that's there as a free resource as well. And of course, I'd like to say to anybody, I am always open. If you guys need help, if you want to ask a question, feel free to contact me anytime. You can just send me a PM on the algorithmic forums, or I did join the Discord channel. So if you guys want to send me a message there, please feel free to anytime. I love talking about this stuff. As you can see, I can't stop talking right now. So I'm happy to help in any way that I can. So again, everybody, thank you so much. Enjoy the rest of your day. And thanks again for joining in. I'll see you next time.